Okay, I turn up my recording. Let's start. Okay, so welcome everybody to attend our AP Physics C Mechanics test prepare class. Okay, this class is try to help you prepare the national AP Physics C Mechanics test in May. So in this class, we assumed you already know the knowledge, okay? Because major time we will focus on help you how to solve the AP Physics C national test problem. So we just make a quick review on the knowledge part, okay? We assume you already know. And before each class, please get the syllabus ready, okay? So before the class, please get the syllabus ready. That's easy for you to follow the class. And in the syllabus, I list I call pre-request, okay? Because when we start each class, we need you, we assumed you already know some basic knowledge related to the topic. So I put that pre-request knowledge in the syllabus. So we said in the syllabus, I also list the reference book. We are using what? We are using the Barron's book. Any kind of word is okay, because we just use a book for the homework purpose, okay? So that's a different word. The homework, no change. So any kind of word is okay. So we said we encourage you just do some homework after each class. And each class, we will also have recorded video available. So just in case you missed some class or you feel some part is hard for you, so you can always review the video later. Spotlight will supply the video. I think right after the second day, okay? Spotlight will make the video available for you right after the next day. So if you feel some part is hard, please review the video again. And we using this Barron's book for the homework. It's chapter based, okay? It's chapter based, but in the end, almost in the end, we will supply you a file of a full practice package, okay? You know, in the College Board website, they only published many free response practice questions there previously, free response. They don't have much multi-choice available, but the package we supply to you, just a whole package with both free response and multi-choice. They are not available on the market, okay? But we only supply to you with, I think, at least half of the class is done. Because right now it's meaningless, okay? Right now we just still review chapter by chapter, so no much meanings to supply you to the whole package. But in the end, we will do that, okay? When almost half of the class is finished, we will supply you the package. Then what I want to say everybody should be work hard right now, okay? Please try your best to finish the homework class by class. Don't wait to the end, okay? Because when it's come to the end of this semester, you have many tests to prepare. Also, we will supply your full package to do that, to do the practice. So you will be very busy, okay? So try to do the homework right now. If you follow our procedure very well, if you work hard enough, I tell you, by our previous experience, most of our students will get a very good score, okay? That is, if you work hard, follow the procedure, most of our students always achieve a great score, okay? So try your best to work hard right now. Each class is a 2-hour session. But in the middle, we will have a 10 minutes break, so you can drink some water or go to the bathroom. Okay. But during the lecture, hope you can pay attention. Okay. Hope you can pay attention. Don't worry about you need to drink water or something. Okay. We have a 10 minutes break in the middle. Then today, what we will talk about? Today we will talk about kinematics. Kinematics in 1 dimension, also in 2 dimension. Then you know kinematics. This is starting point for you to learn the mechanics. But I tell you, in the real test, basic is impossible. They compare some question only related to kinematics is almost impossible. Okay, they always mix up with some other topic. So that is almost impossible. Okay, they just give you a question only related to the kinematics. Basic impossible. But we still need some time work on that. You can say that is reference book, kinematics. They spend 2 chapters. Okay, they spend 2 chapters because this is foundation. Okay, this is foundation. So in this class you may feel easy. Okay, you may feel easy. But very soon you will feel hard. Okay. So we said today we will work on kinematics in 1 dimension, also 2 dimension. We put them together. Okay? We put them together. Kinematics. When you see my syllabus, I first list some confusing concepts like displacements and descents, like velocity, speed, some kind of confusing concepts. Also, we talk about average value and instantaneous value. And among all these confusing concepts, 1 pair concepts I want to special try to make a attention. This is what velocity and speed. Okay, so confusing concept is velocity. Velocity and speed is a little bit confusing. Okay, velocity and speed. Then this time I want to give you 2 arguments. Okay, I want to give you 2 arguments. What are the 2 arguments? We said 1 argument is average velocity. Okay, average velocity may be very different. Okay, may be very different. Very different from what? Very different from average speed. Okay, average speed. This is 1 argument you need to keep in mind. Another argument, this is instantaneous speed. Okay, if we talk about instantaneous speed, then that is what? Just the magnitude of instantaneous velocity. Okay, if you talk about the instantaneous value, then instantaneous speed is just the magnitude of the instantaneous velocity. We will give you an example, talk about they may be very different on average. Then later, when we learn the kinetic energy or centrifugal acceleration, I will talk about instantaneous speed, just the magnitude of instantaneous velocity. So that's velocity and speed you need to pay attention. And also, in AP Physics 1, you already know the constant acceleration case. Okay, constant acceleration case. That is AP Physics 1, but AP Physics C is still heavily tested. Okay, so don't think it's AP Physics 1, you can ignore. AP Physics C also heavily tested for constant acceleration. Then each time we need to know 4 formula. One is V equal to V naught plus AT. Then another formula is not in the College Board formula sheet. That is V naught plus V divided by 2 times T. This is sometimes is very useful. Okay. Then the next formula, delta X is V naught T plus a half AT square. Then we have what? We have V square equal to V naught square plus 2A delta X. Okay. This formula is we used in AP Physics 1, but also heavily tested in AP Physics C. So you have to know that. Then we said how do we apply them we're using an example. So we're using example. We're using example 1. Okay, using example 1. What is example 1? We talk about. Okay, what's the example 1? Example 1, we said I have object moving a constant acceleration, starting with v0 equal to 5, ending with velocity is -1 in a time of 3 seconds. For each motion, I want to ask you what is the average velocity and the average speed associated with this time interval. So example 1 is telling what? You have object is moving, is v0 is equal to what? v0 with is 5, okay, is 5. Then after 3 seconds, okay, after 3 seconds, this is t equal to 3 seconds. They move what? They moving is opposite, okay, they moving is opposite. Then this means v equal to -1, okay, v equal to -1. Then they ask you what is the average velocity and the average speed. Then we said we try to clear up some concepts. Then we said average velocity. You need to know the definition. Okay, you need to know the definition. The definition is like that: average velocity always equal to displacement divided by delta t. The average speed is what? Average speed is equal to the total distance divided by delta t. So that is make the difference. Okay, make the one is the displacement, another is distance. Remember, in O is formula. That is what? That is displacement. Okay, in delta s is displacement. But how can we do that? Each time you need to remember, each one is moving, starting from positive, ending with negative. That is means what? That means somewhere, somehow, they must turn around. Okay, then that means somehow, somewhere, they make velocity equal to 0. Then that means they make d1 distance to 0, to some kind of 0. Then what do? They moving back. Okay, after they got 0, because they have constant acceleration, they will moving back. Okay, they will moving back. So they will moving back to here. They got another d2. That's why they will make this one is a difference. Then how do we solve that problem? Solve the problem for average velocity is very easy. Anybody know what is the easiest way to figure out average velocity? Anybody know that we said we always encourage students be very active in the class. Okay, you are encouraged to ask me any kind of question during the class, during the lecture. Also, you are encouraged to answer me question if you know that. Okay, then I can adjust my class pace. Because if you all know, I say okay, everybody know. I simplify just quickly. If everybody don't know, I talk about more detail. Okay, anybody know how to quickly get average velocity for each process? Then we said when I tell you full formula there, but the second one is not in cottage board. Okay, second one is not in the cottage board. But I tell you, second one sometimes very useful. For example, like this kind of things. We said from this one, we immediately got what? We immediately got V average. Okay, 这是 velocity average equal to what? Equal to delta x over t. 你知道的？ is delta t and t 加 same. 你知道的？ delta t and t is same. You just take the initial as 0. Because you take the initial is 0 加 same. So we got this one. We immediately got the average velocity. This is always equal to v0 plus v divided by 2. This is so easy. Make you solve average velocity. Means so this formula give consequence is average velocity equal to v0 plus v divided by 2. So you say your v0 is initial is 5. Final is -1, because their vector you need capital sign. Then you get what? Immediately gets 2 meter per second. Means immediately get 2 meter per second. So you can say that is make the things so easy, is that? Just make the things so easy if you know that formula. But if it's a multi-choice question, you just answer like that, you get the credit immediately. Okay? If a multi-choice question, you get this credit immediately because it's constant acceleration. But we want to clear up the concepts, so we're using some more detailed way to deal with that. Okay? We said the key problem is moving from here to here with constant acceleration. Then what we are going to do? We do like that. The first part we said, I know v equal to v naught plus at. Means v equal to v naught plus at. Then we say this formula gives us what? Is v, we said this is 10 to -1. 10 to the -1, initial is 5 plus a times t is 3 seconds. Then immediately we got what? Immediately we got a equal to -2 meter per second. Means I ignore all the significant figure things. Okay, significant figure is not covered in AP test. Just make sure you don't give them too weird number. They will give you full credit. Okay, unless you give them very weird value. They may don't like that. Okay, otherwise you never need to worry about significant figure too much. Okay, you don't need to worry about that. Okay. So I said I got A. Then what I try to figure out? I prefer we have a number of ways to do that. Okay, we have a number of ways can do that. But I prefer I find out at what time I got this one. I got this 0. So I using this formula again. I said that it's V when I come to 0. I want to figure out what's the time. Because I want to figure out what the time. So what is the time when I put this 0? I said this one equal to V naught is 5. Then A I already know this is -2 times t. Then immediately I know what my t equal to 5/2 seconds. Means 5/2 seconds. So that is means at this point is what? That's t equal to 5/2 seconds. Means then we said from here come to here, you get this second that much time. That is we call what? We call T1. Okay, we call T1. So how about the T2? T2 we don't need to do. Means we said that the T2 they return back. Okay, they return back. We don't need really worry about it. We can T2. We can easily to figure out T2 equal to 3 minus 5/2. We said this is equal to half seconds. Okay, we can do that. After we do that, we can easily figure out D1, D2 by the second formula, because that's my favorite. This is linear. Okay, this is linear. Very convenient to figure out the value. Then we said, how can we do that? We said my D1, I got a D1. D1, we said this is distance, but this one is displacement. Okay, I take that's delta x1, delta x1. I take distance, absolute value, displacement. Then I got what? I got V naught plus V2 multiplied times t. So I got the value is V naught. V naught is 5. Then at this point, this is 0. It's not. At this point, is 0. Then divided by 2. Then t is what? From here to here, this is 5/2. Means 5/2. Then I got this one equal to what? 25/4. 25/4. We got what? We got 25/4. We got this one is 6.24 meter. So I got the D1 there. Then do the same thing, D2. Then D2 is delta S2, displacement, magnitude. Then we said I still using that formula. This ending point is 0. And this point is 0. This one is -1. Divided by 2 times the time interval from here to here is half. Then equal to what? I take the absolute value, that's 0.25 meter. Means 0.25 meter. So after I make this one, I can manually, I just by the definition, calculate what is average velocity. Average velocity, ds, remember, displacement is a vector. Vector is always a piece of straight line. Okay, vector is always a piece of straight line from the very beginning point to the very ending. Okay, that is dx. That is delta x. Okay, from displacement is vector. Vector is a piece of straight line from the very beginning point to the very ending. So each time you can see what? Each time you can say displacement. We said that's a displacement over delta t. You say displacement equal to what? 6.25. Then you move back 0.25. Then divided by time is 3. Then you get that's 2 meters per second. Means that is average velocity. How about speed? Average speed. Average speed, remember, this is equal to distance divided by delta t. Then equal to what? Distance, we said they move 0.25. Then they move back by another 0.25. Then you divide by what? Divided by 3. Then each time you get what? Each time you get that is 2.17. 2.17 meters per second. So I just using this example tell you how to calculate the average velocity and the average speed. Also, I show you the arguments. Average velocity may be different from average speed. Why I put vary? Sometimes, for example, for a round trip, means that if you make a round trip, then you will say average velocity equal to 0. Means that if you make a round trip, your average velocity will be equal to 0 because they back to origin, displacement equal to 0. Then one student asked D2 means to be negative. I put D2, I said that's distance. Then I take the absolute value, delta S2. Your delta S2 is negative. But when I count the displacement, distance, that's positive, is that distance always positive. That means D2 is that. You say I take the D1, I take the absolute value because that's magnitude. I take the D2, I also take the absolute value because delta S means displacement. Displacement is vector, may be positive or negative, but the distance is always positive. Make sense or not? That's one student asked me, this D2 should be positive, negative or not? I said I means distance, D1, D2 is means distance. Distance, that's absolute value of the magnitude of displacement. So that is means that's always a positive value for distance. 有这个意思 ，OK， 不要大，为啥 ？So very good, OK. We always encourage you, ask me any kind of question because just we try to help you. 为啥 ？If you don't know, you don't let me know why you feel confused, how can you explain is better? 为啥 ？We said we got this question, just clean up some concepts, but that is AP Physics 1. AP Physics C, we don't do that. AP Physics C, we remove constant acceleration condition. Okay, AP Physics C, we remove constant acceleration relation condition. Then AP Physics C will do what? AP Physics C, we use the calculus or integral way. So AP Physics C, we define. So AP Physics C special. Okay, AP Physics special. Just we define A acceleration equal to dv over dt. Then that is what? Then v will equal to integral anti-derivative dt. Then we said v will equal to dx dt. Then we said my x will be anti-derivative v dt. Okay. So AP Physics C, we can use the calculus way. to replace O is for formula. We really can do that. Okay, we really can do that. Some school, even Arthur do that. Okay, some school, even Arthur use the in calculus way replace all the formula. But that is what not I recommend. Okay, because is a constant acceleration is still heavily tested in AP Physics C. If it's a constant acceleration, you are using this way, make the things easier or sometimes much easier. Okay, so it's a constant acceleration, not just at high school, in college, in graduate school, or in medical school. When you take the medical school, take the MCAT, they still heavily test is for formula. So still do that. Okay, if it's a constant acceleration, still do this way, then easier, then you deal with the integral. Then how to do the calculus way? I give another example. This is example 2. That is the easy part. Okay, we haven't come to the hard part because we said real test. They never compile some kind of test question only related to the kinematics. They never do that because that's the foundation. They always combine with some other things together. Okay, they always combine with some other things together. So we said that we take a couple of easy questions before we talk about the hard question. The second example, I just show you a basic calculus. Calculus, what is the example 2? They said the acceleration is given by A equal to ct. This depends on time. This is not constant anymore. C is constant. They said equal to 2. They ask you what's the unit. Okay, what's the unit? Then its unit is easy. Okay, we said sorry, I mixed up the number. Okay, we said it's A equal to A. That's depends on the time t equal to ct. Okay, equal to ct. Then unit of c will be equal to unit of c equal to A over t. A is what? Meter per second square. Then divided by seconds equal to meter per second cubic. Okay. Even you looks at well, but that's it. Okay, straight. Then each time they tell you A equal to what? Equal to 2t. Okay, I ignore the unit equal to 2t. Anyway, this is not a constant anymore. Not a constant anymore. Then you see what? You see that's not a constant anymore. They ask you the bus velocity they tell you velocity at time 1 is 5. What is the velocity at t equal to 2? So we said each time we have no way to using this constant acceleration formula. So we have to what? We have to do the integral. How to do the integral? We using the formula. We said v equal to a dt. Means a dt. Then v is a is equal to what? Is 2t. Is 2t dt. Means 2t dt. Then that antiderivative, everybody know is that this is 2, this is constant out. This is a half t square. But you have to put a constant there. Okay? You have to put a constant there. So we said this is equal to t square plus a constant c. How do we figure out the constant c? Then we need using additional condition. Okay, we need to use additional condition. What is the additional condition? They said at the time equal to 2. At the time equal to what? Equal to 1 second. Then they said velocity is 5. They using this one. You using this one. You said my v is equal to 5 when is time equal to 1. Then plus c. Then I got what? Immediately I got my c equal to 4. Means I got my c equal to 4. That's good enough. Okay, c equal to 4. Then that's what's the unit? What's the unit? Unit is same meter per second. Okay, same as velocity. Make sure this unit is the same as velocity. Then after we got this one, we got c equal to 4. Then we can write down the relation. Is f equal to what? Equal to t square plus 4. Means that's the general relation. for the way，为啥？这是 general relation for the way。这 general relation for the way we are outside. Then what we are going to do? They ask you what is velocity at t equal to 2? We said at t equal to 2. We said at t equal to 2. We said we just go ahead. V equal to 2 square plus 4. 为啥 2 square plus 4? Then we said is 2 square plus 4. We got what? We got is 8. 为啥 is 8 seconds? That's it. Okay. If I made any calculation mistake, please let me know. Okay. If I made any calculation mistake, please let me know. Okay. I do the antiderivative. We got this one. Okay. We got this one. If any calculation mistake, please let me know. Then they also ask the position at t equal to 1 is 6. They ask you what is the position at the t equal to 2. How can we do that? We said the calculus, same thing. That is, we said that is A. That is, we said that's B. Okay, that's B. Then C, we said I using this one again. We said this time x equal to what? X equal to v dt. Okay, v dt. Then v is what? V, we said we just derive the general formula t squared plus 4. Then I make the dt. Then I got what? I got is integral. Is integral equal to what? Equal to 1 over cube is t cube plus 4t plus constant. Means plus another constant. Okay. Don't mix up. Okay. C everybody use as constant. But is constant, z constant, this is different. Okay. This one they give us. Okay. This one is constant we introduce. Okay. Then once again, we said we need at time t equal to 1. Then what is the time t equal to 1? What's the position? Is position is what? Position is 6. Okay. Position is 6. They said the position is 6. Okay. Then we plug in. Plug in is x is 6. Then equal to what? T equal to 1. T equal to 1 that's 1 cube plus 1 is 4 plus c. Means that? Then we immediately get what? We immediately get c equal to what? C is 2. 2 minus is 1. I got what? I got 子睿 common denominator. This is 2. We got 6 minus 1. Got 5. This time, what's the unit? Unit follow the position. This is SI unit. This is meter. Right? This is meter. So this time we got our general relation. General relation is what? 1 cubic t cubic plus 4t. Then make the c. We know this is 5 over 3. Means that we got this one. We got this one. Then we got what? At time t equal to 2. At time t equal to 2. Then we got our position. We said that's 1 zero. We said that is this one equal to what? This one equal to 8. This one 2. Plus is 2 equal to 8. Means that plus what? This is 5 over 3. Means that this is 5 over 3. Then you get what? This is ugly number. Okay, this is ugly number. We said that that's ugly number. How ugly? This is 3. This one is 13. This one is 13. Plus what? Plus 8. Plus 8. You can say this is equal to 3. This is 24. 37. 37 meter. That's it. Okay. That is calculus way. That is basic calculation. Okay. That is basic calculation about kinematics, AP physics 1 way or AP physics 3 way. Okay. We said that we have a basic calculation, AP physics 1 way, AP physics 3 way. That's it. Okay. That's it. Then we said that we got that fundamental knowledge ready. Then we talk about the hard one. Okay. What's the hard one? Hard one, when they test your kinematics, most of the time, they will combine with the graphing things. Always, okay. Basically, like this kind of easy question, they may only test you multi-choice part. Okay, they will do a multi-choice part. Okay. Later, when we talk about the kinematics, when we talk about the dynamics, we will show you how they calculate, they test the calculus in that dynamics part. Okay, but kinematic part, no big deal. Okay, no big deal. Then we said that if they test your hard question, then combine with graphing. Then we talk about example 4. This is really hard. Okay, example 4 is really hard. That is related to what? Is experimental measurements. Is experimental measurements. They will always have one question related. Okay, AP Physics C only have 3 free response questions. Okay, any kind of AP Physics C, no matter mechanics or EM, they only have 3 free responses. One of them must be related experiments. Okay, somehow, some way, they need related experiments. Then we said, what is the example 4? Is 2013 year. What's the test year? They give you motion sensor. Everybody knows that. Okay, they give you motion sensor. They make an error tracker. Why they use the error tracker? Because they want to reduce fraction. Then error tracker reduce fraction. Then you have an object moving. Make the error tracker do some experiments. They said students place 0.4 kilogram glider on the error tracker without fraction. Hold so that it's touch uncompressed ideal spring. We need your knowledge, okay, spring. Then, as shown in the figure, students push the glider, compress the spring by 0.25 meter. Then, at the time t equal to 0, students release the glider, and the motion sensor, they began recording the velocity of the reflector at the front of the glider as a function of time t. Then the data points they put on the table. They said at the time t equal to 0.79, glider lose the contact with the spring. They give you the measurements table because this motion sensor. Right now it's fancy. Okay, right now they have a motion sensor. They can easily figure out the velocity. They want to, on the axis below, plot the data for v versus time t. Then drawing a smooth curve and best fit the data. Then they want to label it correctly. That is AP Physics C mechanical style. Okay. AP Physics C mechanical style, they ask you do a lot of graphing things. Okay. They ask you do a lot of graphing things. And each graphing is noisy. Okay. Each graphing, we said you also need to know some other knowledge. Okay. We assume you already know some knowledge. Okay. If you don't know, I will talk about you. But the major part is graphing. Okay. We said is a major part is example 3 is graphing. Okay. We said is graphing things, what we are going to do. We said, okay, we said it's graphing things. We said example 3, what we deal with the graphing things. This one is hard, okay. Honestly speaking, it's noisy, it's hard. So they put a glider, don't consider the detail, okay? If you have the chance to do the experiments, you will see glider, you just think of object. And they give you that table, but they want to make the graph. You need to make it carefully. You make it carefully. What's the carefully? Time when is over 0.75 in the table, 0.75. You can say your velocity basically doesn't change anymore. Why? You need to understand at that moment, they said at the time t equal to 0.79 seconds, the glider lose contact with the spring. Okay, they lose contact with spring. Okay, we said they lose contact spring. They add 0.78. If they lose contact, also the glider is what? Fractionized. Glider is fractionized, also perfect horizontal. Perfect horizontal, you will see what? That will be conservation of energy. That is means speed is constant. Speed is constant. Then after you know that information, you can make the graph easier. Okay? You can make a graph easier. You can make the graph easier. Why we said I put this graph. Then is time t. Is time t. We said that's time t. Then is position. Is velocity. They said is velocity. Is velocity. Then you plot this graph. 这是 0, 0, 这是 one point. 那个啥 ？Then is 0.25 啊，这是 another point. Okay, another point. Then is another point. 这是 so hard for me to 那个 OK， 这是 another point. OK, with another point. 这是 some kind of small error. OK, we got this one. Then what's the graph will looks like? Graph looks like my brain is not good. It's a curve. Constant. Okay, it's like that. It's like that. It's like that. Like a curved, then flat. Because why is flat? Because they are leaf contact. Energy is conserved. You should be know that information. Then it will be constant speed. And okay, I will talk about more detail. How can you know the curve like that way? You make it better. Then we said the students wish to use the data to plot the position S versus the time t for the glider. Describe a method. You can do that. Okay, before we do anything, before we give more detail on this kind of things, we said what we are going to do. They ask you what? They want to figure out to do S versus T. Then we said that is B. We said is what? This is B. We said is what? S versus T. Your S, remember, this is equal to V. It's V dt. Means that is one is what? It's the area under the graph. Means that it's the area under the graph. So what you tell them? You tell them a method can use to do that. You need to tell them what, they give you 4 credit. You tell them integral, they will no credit. Okay. Why? If you want to do the integral, because you have to know the function, is that? If you really want to carry out any kind of integral, you have to really know the function. You use a computer, you can do that. But that is what we call area. If it is no function, you need to calculate the area. You need to count by count the area under the graph. Okay, by counting the area under the graph. Okay, you tell them that is you can do by counting the area under the graph. Okay, under the graph. But I tell you, this is hard. This is really hard. In my syllabus, make sure get my syllabus. They give you graphing paper there. Okay. In my syllabus, you can see they give you the graphing paper, so you can count the area. But when you count the area, I tell you this is still hard. Okay, this is still hard. Why is it still hard? When you try to count the area, basically they give you a graphing paper. You need to count how many boxes there. Okay, you need to count how many boxes there. Yes or not? When you count the area, how do you figure out the area on graphing paper? You need to count how many boxes there. I have area, that's by box. Then you need to know one thing. One box. You can say you have a small box or big box under the graphing paper. You need to figure out one box, how much number they represent. Okay, you need to know one box. This means how what's the value. You need to know that. Counting the area, they give you the graphing paper. Graphing paper, they have a small box, they have a big box. then you pick up the small box or you pick up the big box. I tell you, pick up the small box, make your calculation more accurate. Okay, you pick up the small box, make your calculation much more accurate, but take you too much time. Okay, if they give you that is a graph, you count the small box, they take you too much time. The official solution, they did a big box. Okay, so the official solution, they did roughly how many big box. Okay, how many big box? We said they describe a method you can use to do is one. Then number one, you tell them by counting the area on the graph. Means that's you tell them. Then two, they sketch the position s as a function of time t for the glider. Then label all the important things and what you want to do. They want to say, you really count the area, then you try to figure out the position, because even AP phase 1, not just AP phase C. AP phase 1, we said if you get velocity, you try to figure out the position. What's the time t? How can you do that? You count the area. So hard. Okay. So hard to count the area. Then I tell you, if you really count the area, because you need to count at a different time moment, you count the area. Then I tell you, that's basically it's like that. It's not. So you need this a little bit noisy. Okay, no such. Okay, that's anyway, something like that. Okay, you need to know curve y like that. Y is speed line. We said if you know the physics, then much better. Then you just purely count the area, because number one, no way you really do the integral, because we don't know the function. You count the area. You need to count the area when t equal to is point. You count the area. Then when t is equal to point, you count the area. When t equal to is point, you count the area. Then you know s versus t. You make the things very noisy. Okay, Then what we do? Okay, sorry about that. Okay. We need to make a current pumpings. Okay, we need to make a good current pumpings. What's the good current pumpings? We need to say, you need to get, we need to make a good current pumpings. Okay, good current pumpings. Good current pumpings. What means good current pumpings? You say, we said after is point. Okay, roughly we said after. They told us is what? They told us after 0.79. Okay? 0.79. After 0.79, they lose the contact. That means constant speed, because energy is conserved. Before they got the contact with spring will push the glider. They will transfer potential energy to kinetic energy. So that's why the glider will speed up. Okay, that's why glider will speed up. Okay, glider will speed up. Glider will y is speed up. Then, but after that, this velocity constant. If velocity is constant, I tell you, we need to remember that formula. Means that we need to remember the formula. We said when the velocity is constant, it means acceleration equal to 0. If velocity is constant, acceleration is 0, my s 这是 my delta x equal to v naught t plus a half a t square。 we use formula， v 是 constant 的，这是 leaf 的 loss 的loss 的 contact 的，也是 x relation equal to 0。So my delta x you can say 这是 x equal to 的 delta x always x minus x naught。Then you can say 用 z point 就跟 v naught t。Then 有没有 say 我的？一是 x versus t will be straight line， will be straight line。So that is you get correct, no problem. OK， 这是 y， we got this straight line. OK，make sure this part you have to join carefully. You use your ruler. Make sure 这是 straight line. OK，make sure 这是 piece of straight line。这是 piece of straight line。But figure out this piece curve and that piece curve is critical. OK，even your this y you can mark the measurement point carefully. You can get this curve. But to get that curve, to get that piece curve, not that easy. How can we do that? We said when you try to do the graphing, don't just really focus on the number, okay? Because if you really focus on the number, just very hard to get accurate graph. If you just focus on the number, especially when you try to do the integral, this is official solution. They said they count the area, but it's very hard to show this curve. Then what's the physics behind it? Anybody know that or not? Physics behind it, you push your glider against a spring. Okay, you push your glider against the spring. Then what does that mean? If you push your glider against the spring force, everybody know that, yes or not? Spring force equal to minus ks. Minus ks. Spring force is minus ks. Then this force will do simple harmonic motion. But this one will not do full simple harmonic motion because my glider is not attached. My glider is not attached, so they will not do full oscillations. But at least when this part contact with spring, then simple harmonic motion is what? Solution is what? Solution, I tell you, by this initial condition, my x will equal to negative a cosine omega t. Everybody know that or not? Because in the t equal to 0, you compress, is not t equal to 0, you compressed. This means what? That means you compressed. This means you get negative maximum. Okay. Don't try to challenge me. That is my initial glider, the thing is 0. Don't try to do that because that is general solution. You take the initial position like the marked s equal to 0. Doesn't matter why. They just shape the graph up. Okay. They just shape the graph up. I just want to show you the curve. Okay. X with t equal to negative a cosine omega t. If you already know simple harmonic motion. If you don't know, you will learn very soon. Y is like that because t equal to 0. You compress the spring. Okay. T equal to 0. You compress the spring. That is in physics. You get maximum negative. Okay. You get maximum negative. So this one will be like that. How about the velocity? Velocity will equal to ds dt. Will ds dt. ds dt equal to what? ds dt will equal to what? Will equal to a omega sine omega t. Sine omega t. Why we know this one function is important? Then we know y is curve. y is a curve. We know the function. We know the function. We know the cosine function. Instead, we know the cosine function. What the cosine function looks like? What the cosine function looks like? Like this one. Cosine function. T equal to 0 minus a. Here. Is here. The cosine function is like that. Like that. Instead, what's the sine function? Sine function. T equal to 0 equal to 0. Then sine function will be like that. Sine function like that. Then this time, I just want to show you this part. Okay, we just show you. This part, this curve, this curve, this curve. We said this curve. That is curve. What do we need? Why? Because that from here to here, that is from maximum compression to back to origin. 那个啥 ？You see spring, you compressed. Spring, you compressed. Then it's maximum compression at here. Then at is 0.79, you back to origin. Just come to here. Then you see what? Is curve corresponding to what? Corresponding to here. Corresponding to here. Then is one. We said that you get this one, you must get that one. Then is part maximum compression is 0. Then moving forward, this is V. Okay, that's the position. This is V. So this part is corresponding to what? Is corresponding to this part. So that is when I plot the graph. Basically, I just roughly figure out the value. Then I based on the physics, I got this piece curve. Because that is piece curve. They make this more flat. Okay, they make this more flat. Then this piece of curve. Then I got this piece increase. But after that, flat. Conservation energy. Then after that, straight line, constant velocity, straight line. But remember, this curve comes from that part, from maximum compression to origin. Then current pounding is velocity from maximum compression to origin length. That is part. Why they have a curve here? Then why have that curve there? That is make you get the graph much more easier, also much more accurate. Because you just want to show what kind of curve. Otherwise, you don't know curve like that or curve like that. Because it's so hard for you to really base on the area under the graph. So that is we want to learn how to do the graphing. Okay, we need to take a 10-minute break. Okay, so we take a 10-minute break. We drink some water or go to the bathroom. So we back 8:10. Okay, so take a 10-minute break. Drink some water or go to the bathroom. We will back to you. Okay. Okay, it's 8:10. We start. Okay, that is we want to kind of remind you when even they ask you graphing, they taught you this is based on the experimental data. This is really required to do the experiments. Okay, but in the test, I always recommend you know when you try to plot the graphing, what is the physics formula behind it? Okay, I really recommend. Okay, before you do the graphing, you need to know this physics formula behind each piece of graphing. Because only when you know the physics formula, you know that piece of curve, then you can make that correct. Only you know that is piece of curve, you can make that correct. Just make it much more easier, okay, much more accurate. Otherwise, you just spend too much time. You just try to figure out exactly what the data point looks like. Make sense? So that is graphing things. They always like to test you. So we make this graphing, then you calculate time at which the glider make contact with the far right. They want to calculate how much time make the far right. How can you do that? How can you do that? Make the far right. Far right is what? Your displacement is at 2 meters. You see that? Because this glider is this air track. Air track is only 2 meters. Okay, we remove this part. We said that's we recommend you need to know the physics behind each piece of graphing. That make it much more accurate. Okay, much more accurate. Then we said what we're going to do next. They ask you what? They calculate the time when is contact with the far right. This is question C. Question C, we said question C is happen on what? Far right. This means delta x will move to 2 meters far. Means 2 meters far. Then you need to know when is delta x move to 2 meters far. This delta x really split into 2 parts. Makes sense? This is really split 2 parts. Why is it split 2 parts? Because one part is get contact with the spring. So get contact with the spring, that's at the T1 part. Then they tell you equal to 0.79. Then how much distance you moved? How much distance you moved? You moved the distance D1 equal to 0.25. It's 0.25. They said that that's a compressed spring by 0.25 meter. Means 0.25 meter. So we said T1 equal to this value, D1 equal to this value. Then what's the rest of the distance they will going to travel? Then we said the D2 they have to be travel. D2 they have to be travel is 2 minus 0.25. 0.25. Then you still have what? You still have 1.75 to travel. 1.75 meter to travel. So that second part, they will travel a distance 0.75. But for this part, we already know this constant velocity. Means that constant velocity. Because they lost the contact, then energy is conserved. Then it's constant velocity. Constant velocity, they give us the value. What's the value? 0.5. Okay, we take 0.5. Then make the things easier. Okay, we said that this make the 0.5. We make the things easier. Means that we make the things easier. 0.5. We said that this is meter per second. Means that. Then what is the second part of time? What's the second part of time? What's the second part of time? Second part of time, we said T2 will equal to what? Then 1.75 divided by 0.5. 0.5. Roughly they equal to what? That's 3 point. That's 15. 15 is 25. That's 5. That is seconds. Means that's seconds. Then that is roughly equal to 3.5 seconds. 0.5 seconds 0.5 seconds is roughly this move 0.25. Then another piece of distance is 1.75. But we know the roughly travel velocity 0.5 make us calculation a little bit easier. Then we said the total time they come to the find, then 3.5 plus what? Plus 0.79 equal to what? Equal to 4.29 seconds. 4.29 seconds. So we said we got 4.29 seconds. Then travel to the end. That is question C. I think this one is easy. Okay, this one calculate the time, glide, make contact with the far end, because you need to come to delta equal to 2 meters. This is whole air track. So that is, I think, that is make the things easier. Okay, make the things easier. What is their official solution? Official solution, they count the area. Okay, they count the area. Count the area, make the things much more noisy. Because they didn't tell you, you have to count the area. Okay, they didn't test you, tell you, you have to count the area. But the official solution, they count the area. If you count the area, make the things much more noisy. Okay, count the area. If you count the area, much more noisy. One, number one, count the area. You count the small box or big box. The official solution, count the big box. Count the big box, they involve a lot of area. Okay, this is how many big boxes? They involve a lot of area. Then they count the area. They count the big box. Okay, they count the big. They count the big square. Okay, they count the big square because we have a small square. We have a big square. You another thing, that's in case someday you really need to count the square on the graphing paper. You need to know one square. What that means? Okay, you need to know one square what they means. One square what they means from the graphing. Okay, from the graphing, we say the one square. That's a big box. Okay, big square. Big square what they means? In the Y, you can say one big square is 0.25. What is the X? The big square. That's what? That's 0.5. So one big square, that is means 0.125 seconds. Okay. Sorry, meter. Okay, this meter. You use the velocity multiple time. That's you get meter. Very noisy. Okay, very noisy. You count the big square. They count the official solution. Count the big square. Big square. You need to understand one big square. What does it mean? They means one big square. This is Y 0.25. This is what they mean. X you say this means 0.5 seconds. You multiply together. This is 0.125 meter. Then you count roughly how many big square they are. You figure out they move to here, how much distance they move. Then rest part how much distance they move. This is very noisy. Okay, I don't recommend this way because either way you get correct answer. They tell you at T1 is 1 lose contact. This means you D1, of course you get 0.25. You release from the spring. That's it. Okay, that's it. So that is we said how to do the calculation in part C. Also, just in case someday you really need to count the area, make sure you need to know each piece area what it means. Okay, each piece area what it means. Each time it means is 1 multiply is 1 to get is 1 meter. Okay, so we said this graphing sometimes may be very noisy, especially area. If you take the slope, that's no big deal. Okay, If this you take the slope, I will say go ahead, do that. This is easy. But area is hard. Okay. So they test you calculate the time. We know that. Then also calculate the force constant of the spring. Okay. Then that is I don't know if you already learned. Okay. But anyway, I just quickly give you a solution because that is not a major part for today. Okay. Someday we will do that. Okay. Someday we will do that. They ask you calculate the force constant. This is D. Okay. This is D. If you learn the spring conservation energy, you will know this is a half m v maximum square, v maximum square equal to what? Equal to a half ka square. Okay, a half ka square. If you learn the spring things, you will know that because we know all the information. Okay, we know that the mass m is 0.4. Means that we know is what 0.4. Then we know v maximum. We also know V maximum, that is 0.5, right? 0.5. Then we know the amplitude is 0.25. Means that because the comparison, okay, the comparison is 0.25. We put all the information in, then we can find out the spring constant. We can find out the spring constant. So they want to make use measurements, then to do the spring constant, just Newton per meter. Means that. Anyway, if you haven't learned that, doesn't matter. Okay? We have a special class talk about the spring things. Okay, this is spring things. We said we put this one. I got this one. E, they said experiment is run again, but this time the glider is attached to the spring. Then they will do what? They will do the simple harmonic motion. Okay, they will do the simple harmonic motion. They want to determine the amplitude for the oscillation. Then E again, that's a simple harmonic motion things because they don't test your kinematics directly. Okay, usually they never do that. Okay, they always combine with some other things. Determine the amplitude. We said the amplitude. We said your maximum compression is 25 meters. That's it. Okay, this is one. Okay, so one. Then they also determine the period. Period. We said that's a period equal to 2 pi. Then I'm okay. Means that then I'm okay. That is maybe you don't know. Okay. Maybe you haven't know. Okay. Maybe you haven't know. We said that is a period equal to is 1. If you're using, you know the M, you know the K, then you can do that. Okay. You can do that. But any other way, you can use this one to find out the period. Any other way, graphing. Okay, each time they tell you the graphing. Each period you can use another way. Okay, you can use another way. Period equal to what? Period equal to what? 4 times 0.79. Is that? Because from maximum compression back to origin, that's 1/4 of period. Okay, from the maximum compression, you back to the origin, that's 1/4 of period. But if you want to figure out the period, that is really means you need a multiple by 4. Okay, that is graphing things. Okay, this is graphing things. This is graphing things. You can say this one equal to what? Equal to 3.16 seconds. Okay. Using this one is better. Okay, because that's based on experiments. Okay, this is based on experiments. Using this one is better. Okay, because you tell you from the maximum compression back to origin is take 0.79 multiple this one. Makes sense? So we said that is how to solve this kind of graphing things. Major part is graphing kinematics. It's not kinematics just tell you try to bound displacement, velocity, acceleration is things together. So that's the major part is like that. Okay. So that is kinematics for 1 dimension. How about the kinematics for 2 dimension? Kinematics for 2 dimension, that is major part is projectile. motion. Okay, major part is projectile motion. We said we talk about kinematics. We want to put all the kinematics together because this is foundation. Okay, this is foundation. When we deal with mechanics, and you can say Barnes' book, they take 2 chapters on that. Okay, they take 2 chapters on that, but in the real test, basically they have no way to compile a question just as the kinematics way. Okay, so 2 dimension. So basically, we try to figure out what we try to figure out that is projectile motion. Projectile motion. Remember, that's a constant acceleration. Is constant acceleration. Remember, this ax equal to 0. Horizontal always equal to 0. Then ay is what? Ay equal to negative t. Ay equal to negative t. So if you realize this ai is equal to 0, ay equal to negative t, all you need to do, then apply is 4 formula. So 2 dimension for the projectile motion, you just apply is formula, is 4 formula, apply with is 2 condition for the projectile motion. X components 0 acceleration, y components negative g. G, remember, everybody know G equal 9.8. Okay, 9.8. Oh, you use 10 is okay. Okay, you use 10 is also okay. So we said that is the projectile motion. Projectile motion. What kind of complicated problem they can give to you? They can offer to you even most complicated application. Like this case, okay, only most complete application. Like this case is looks like what? I give you the example. Example 6. Okay, example 6. This is basically this hardest question they can give you. Okay, hardest question they can give you on this part. That is some school do the homework. Okay, do the homework problem, but in the real test. I think it's still too hard. Okay, too hard. But what is one? Is one is said they have make a projectile motion before incline. Make a projectile motion before incline. Then before incline, we said before incline. Then they make this one. Okay, they make this one. They make this one. They said it's V naught. They make this V naught. Then they said they have an angle. Here is phi. They have another angle. Angle is theta. This one is much more complicated. Okay. This one is much more complicated than our regular projectile. Our regular projectile, this is what? It's on the ground. Means that this is on the ground. It's on the ground. You just make this one. Then they flying at the back. That's regular projectile. But this one, they make it harder. But don't worry about that. Why? Because they just need to follow its 2 acceleration, combine with its 4 formula. That's it. How can we do that? We always follow standard procedure. We say that is V naught x equal to V naught cosine phi plus theta. Means that we know V naught y is always equal to V naught sine phi plus theta. We always just go ahead to do that. Then they want to ask you, when it's falling on the incline, they want to ask you, figure falling on the incline, what is the range? What's the range? Then they falling on the incline, what's the range? I said, okay, I follow its range, but I don't care its incline length. I care what's the happen to my delta x, what's the happen to my delta y. It's not, I just care delta x, delta y, and delta x. Because its 4 formula only apply to the x component, y component, because they live constant acceleration. This is easy for us to deal. Then we said my delta x equal to what? My delta x, everybody know, delta x equal to what? Equal to r cosine theta. Then my delta y equal to what? Equal to r sin theta. Means that delta y are sine theta. We got Vx, Vy, delta x, delta y. We are done because we got all the information, try to apply for formula. 为啥 ？We got all the information, try to apply for formula. So what is the information? We using this one. We using the third one. We using the third one. We got what? We got delta x. We got delta x using this one. Using third formula. V0x naught. Then that is V naught cosine theta plus psi. That is t. 为啥 ？We got delta y equal to what? Equal to V naught sine phi plus theta t minus a half g t square. 为啥 ？g t square. This kind of equation we call what? We call parametric equation. We call parametric equation. How do we solve the parametric equation? We eliminate common parameter. This is t. So that's t equal to what? We said this is t equal to delta x. But remember, delta x equal to r sine theta. Okay, I put delta x equal to r sine theta. So that's r sine theta. Is that r sine theta divided by what? Delta x equal to r sine theta divided by v naught cosine theta plus phi plus theta. Yeah, c. Okay, the c. Then what I do? I substitute this t to here. I substitute this t to here. Then that is need some calculation. Okay, this is basically most complicated things. They never really do that, but they may have some concept related to that. Okay, we said delta y equal to r sine theta. We put delta y equal to r sine theta there. Okay, r sine theta there. Inside delta y equal to r sine theta. Then I make v naught sine so phi plus theta. Means then we put this one. Then t equal to r sine theta. Sine theta is v naught cosine theta plus phi. Means then minus what? Minus a half g t square. What's the t square? T square is r square sine theta square. Okay? Sine theta square. Then over what? Over v naught square cosine square theta plus phi. Means theta plus phi. I got this one. I got this one. So what do we do? We eliminate something we don't like. Okay. What do we don't like? We don't like. We have r square that's bothers us because we try to figure out r. I cancel out this r. Wave is r. Then is square 杠. Means is square 杠. So that is benefit for us. Okay. That is benefit for us. We try to figure out this item. So I make that item in one side. I try to figure out this item. We try to figure out this item. Then we said I can put this item in one side. I also cancel out v naught. Okay, I cancel out v naught. Then I said I put half g. Is I put gr. Means I put gr. Then is gr sine r. I have sine theta. Okay, sine theta. First we said sorry. We said that is delta x equal to r cosine theta. Okay, sorry about that. Okay, this is r cosine theta. Okay, this is terrible. Sorry. Okay, terrible. Sorry about that. Okay, this is cosine theta. Okay, is delta x equal to r cosine theta. Okay, sorry about that. Okay, so that's why I failed. That's why. Okay, why I failed. That's why. So that's a cosine theta. This is cosine theta. Remember, this is cosine theta. Okay, sorry about that. Okay, sorry about that. That's cosine theta. Okay. So that's cosine theta. Then cosine, we said that that's a delta x equal to r cosine theta. You put r cosine theta, you get r cosine theta divided by put this one. Then we put this r cosine theta square here. R cosine square theta here. We got what? We got gr cosine theta square. I got 2 v naught square, then cosine square theta plus phi, theta plus phi. I make this item to here, then I move all the item to there, then we set equal to what? I set this cosine theta plus phi, then that is sine theta plus phi, then make a cosine theta. Then I do the common denominator because it's sine theta move back. I do the common denominator. I do the common denominator. We got what? I got this cosine theta, cosine theta, sine theta. I sum this item with this item. I do the common denominator because another item just have sine theta. I do the common denominator cosine theta plus phi, sine theta. Then each time we need to know basic trigonometry. Sine angle, cosine minus cosine is angle, sine theta. Then what we got? We got sine, cosine, cosine, sine. We got what? We got this one. We got this one is cosine theta plus phi. Then sine cosine minus cosine sine. Everybody know that's the formula is sine what? Sine cosine minus cosine sine. This sine is angle minus is angle. Sine is angle minus is angle. You get sine phi. You get sine phi. After we simplify like that, then we do the simplification again. Why? I cancel out this part with this square. With this square. Right? Before I didn't do that because I know I need to do common denominator. Okay, I need to do common denominator, so that's I didn't do that. So I cancel out this one with this one. Then this time I figure out the range formula. Okay? I figure out this complicated range formula. This is equal to what? This is equal to 2v naught square. 2v naught square sine phi, then cosine theta plus phi, then divided by what? Divided by is g cosine square theta. Means cosine square theta. So we spend that much time, we derive an ugly formula. Then AP Physics C, sometimes you need to have a science to make a judgment. Is it correct or not? AP Physics C, we need to make you have a sense to judge a formula is correct or not. Then in AP Physics 1, also in your school, you must learn the simple range. Okay, you must learn the simple range. What is simple range? What's the simple range? Simple range is like that. Okay, simple range is like that. If you have a ground, then if you just have a simple ground, you send out v naught with theta, then they move this one, they move range. Means you move the range. Everybody, this time we said I make this theta, I make this phi. This time we said this one I call this angle is phi. Okay, sorry, I try to compress this one. I call this angle is phi. Okay, I call this angle is phi. This time, I believe every student should know how to do that. Okay, everybody should know how to do that. Figure out this range. This range, I put in my syllabus. Okay, I put in my syllabus because you can very easy to do that. Okay, you can very easy to do that. You can very easy to do that. You get that formula. You get that formula. We said I put in the syllabus. That formula is what? That formula, range formula is what? If I change the angle to phi, that formula I gave you in the syllabus. And that's very easy to derive. Okay? It's very easy to derive. You compare, it's not the noisy things. That's equal to 2 theta over g. Then what we want to have the sense. We want to know every time you derive a complicated formula. Every time you derive the complicated formula, I'm using 5 here. Okay, I'm using 5 here. You derive complicated formula. How can you know this complicated formula is correct or not? If a complicated formula, you want to make a judgment is correct or not, then you just try to make this complicated case back to the simple case. Okay, you just make this complicated case back to the simple case. How to make this complicated case back to simple case? That is, you make this incline flat. Okay, you make this incline flat. That means if we set theta like this one equal to 0, if we set this theta equal to 0, that is make this back to horizontal. Horizontal, you see what's happened. This time we said if you make this one is theta equal to 0, you get what? You get 2v naught square sine phi. Then cosine what? Cosine. You set theta equal to 0, cosine phi. Then you get what? You get this g. Because cosine 0 equal to 1. Okay, cosine 0 equal to 1. Then I got what? I got everybody know trigonometric formula. Just v naught square 2 sine phi cosine phi. Everybody know just sine 2 phi. 为啥 sine 2 phi? That is the way how we track a formula, complicated formula, if it's correct or not. We say the complicated formula usually corresponding to a complicated case. So how to make a complicated formula back to easy formula? You just make this complicated case back to easy case. That means we just set theta approaching 0. Okay, we set theta equal to 0. Then make this incline back to this one. Make sure everybody know how to derive this formula. Okay, make sure everybody know how to derive this formula. This is much easier than we derive that formula. Make sense? So I using this kind of formula just to tell you one story. Any complicated formula for complicated case. If you make the case back to simple case, the complicated formula should be back to the simple formula. We will later, next class, when we talk about the dynamics, we said we will have a simple situation, a similar situation. How can you track when you derive some complicated formula? How can you know that's correct or not? Because that help you make the judgment. Okay, this help you make the judgments. Okay. Then we talk about the last question. 这是 example 7. 这是 another AP test. Again, that is very hard to get any kind of question. It's purely by kinematics. Okay, they always involve some other things. Each time they said, starting from rest at point A, 50 kilogram person swing along the circular arc from rope attached to the tree over lake. Point D is at the same height of A. Distance point from the attached to the center of mass person is 6.4. Then they ask you, person swim 2 times. Each time let's go at a different point. At the first swing, the person lets go when it's come to the C. Then second time, let's go come to the D. Then they ask you, what is the trajectory for that person? We said that each time they ask you the projectile motion, but they always combine with something together. Okay, they always combine with something together because basically it's hard to compile the question purely by kinematics. Okay, purely by kinematics. Then we said, how can we do that? Okay, how can we do that? We said, that's the last question. We said this is example 7. That is, we said this is from AP test. AP test, they said, I have a person is here. Then they like that. they make that. Then they make that. Okay, they make that. They make each one. They will go back to the same height. They will go back to the same height. And here, why? Conservation energy. Okay, we said we have to combine with some other knowledge. We said this is from A come to D. Each one with the same height. The reason with the same height is because they conserve the energy. Then 这是 lowest point， 这是 moving fast， moving fast 是 B。Then they have another point is what? Another point C is C， 是 C。They ask you what? They ask you 这是 person。swing， 这是 person is swing。Then letting go at a different point. Then if point C, they ask what happened. Then if point B, and if point C, what happened? And if point D, what happened? Point D, remember, this is maximum height. Then each one is means at each one equal to 0. Each one equal to 0. Means equal 1 0. But C is what? Then you need to know another things. Is C velocity always along the tangent direction? Okay, velocity, remember, always along the tangent. Okay? Velocity always along the tangent. So velocity always along the tangent. That's initial velocity. If at this point release, makes sense? So we said velocity always along the tangent. We can prove that in AP Physics C. Okay, we can prove that in AP Physics C. This is always along the tangent, but that's under the gravity. Okay, under the gravity. Under the gravity acceleration, they must do the projectile motion. They must do the projectile motion. You can see what's the path. Okay, what's the path? They must be like that. They must like that. It's not that they have to go. Go when they come to some height. They come back, then falling on the ground. Okay, they cannot falling on that much. Okay, they falling on where's the water? Water is somewhere here. Okay, water is somewhere here. Okay, they falling on there. Okay, so that's the projectile motion. Okay, projectile motion. That's number one. If at D is velocity equal to 0, D velocity equal to 0, then what they are going to do? They just do the free fall. They just do the free fall. So D path just do the free fall. Only when they release C, they carry the initial velocity. Okay, they carry the initial velocity. You will say C initial velocity make the have projectile motion. Okay, projectile motion. So you need to join that diagram at point D, free fall straight line. Point C, they have initial velocity. They make projectile motion. Okay, they will make projectile motion. So that is you need to know. They ask you represent the projectile of central mass when you make this happen. Make this happen. So that is 2 parts you need to mark. The other part, this is related to some other things. Okay, what's the other things? The central mass on the platform is A. That's 4.1 above the surface of the water. And calculate the gravitational potential energy when the person at A, then relative to when the person is surface water. Okay, I believe everybody already know that. Okay, I believe everybody already know potential energy. Okay, because no matter what you are doing in school, everybody already know the potential energy formula. Okay, we say that A is the hard part. Okay, A is a little bit hard part. Need to see what's happen. B is easy. Okay, potential energy is everybody know is MTH. MTH. So M they tell you this is 50. Okay, they said this is 50. G they said you say it's 10. Height is 4.1. 4.1. So you get together equal to 20, 50, 20, 50 joule. Makes sense? That's everybody know. 为啥 ？Then C is also no big deal. C is central mass and B is lowest point. Is 2.4 above surface. Calculate speed at B. Calculate speed at B. 这是 also conservation energy. OK， 这是 also conservation energy. We said that this is called conservation energy. E1 equal to E2. We will have a special chapter talk about it, but we said they always combine kinematics with other things. Okay, otherwise they cannot compile hard question enough. E1 we said E1 we already know this is equal to mg h1. H1 is equal to what? H1 equal to 4.1. Means that in the beginning 4.1. No kinetic energy. E2 is a half mv square plus mg plus mg. Then what is get? What is the height? Is 2.4. Okay, 2.4. Remember, I didn't do it. I didn't apply my initial potential energy. Is value. Why I don't do that? I'm afraid make mistake. Then carry to here. Okay. Remember, they ask your potential energy. You give them value. But when you apply conservation energy, I recommend you rewrite down the formula again. Why? Because we cancel out the M. Means that we reduce the calculation. Okay? We reduce the calculation. Then we don't need to worry about the carried mistake. Okay? So you redo them, you carry out the M, make the calculation a little bit easier. Also, you know what? You don't need to worry about carry out the mistake. Then we got this one equal to 5.8 per second. Then that is nothing related to kinematics. Okay. Then D is back to D is what we want to emphasize. Okay. D is what? D is really kinematics. Okay. D is what? Suppose there's a person swing from the rope. 这个 time. Let it go at B. Let it go at B. Then what do they want to do? Calculate the range R moved from where the person release rope at B to the person hit the water. They want to calculate the R, the horizontal distance from the person released the rope at point B to where the person hit the water. Again, you need to know what? When they release the rope, the velocity always tangent to the trace. Okay, the velocity always tangent to the trace. So we said velocity is always like that. Okay, velocity always like that. But velocity like that, everybody know that will be like this way. They will like this way. They will like this way. Everybody know they will like that way. So they want to calculate the range is here. Means that they want to calculate the range is here. Because you release at the point velocity is horizontal. Velocity is horizontal. They make this piece. Then they want to calculate what is R. How to do that? This part we said that is back to kinematics again. Okay, that's back to the kinematics again. Because number one, you need to figure out how much time they fall into the water. Then you will say how much range they travel. How much time they fall into the water. This is vertical behavior. Vertical behavior, I use this formula, but I change to everything to y. I change everything to y. I said W1 V naught yt plus a half a yt square. Means I change this one. Then each time, how can you plug in the value? Plug in the value, you need to choose a positive direction. Okay. Plug in the value, you need to choose a positive direction. Like this one, if you always choose upward as positive, okay? If you always choose the upward as positive, like we write down A1 equal to minus G, you need to make sure delta Y is what? Delta Y is vertical. That is initial. That is final. 为啥？有this one is initial, is final, doesn't matter. Y components 就是 vertical. Remember, initial is in the up, then is final is below. So make sure you plug in delta Y. You have to plug in what? Negative value. Okay. If you pick up the value, is what? Is always follow A1 equal to negative G. This means you take upward as positive. Remember, delta Y equal to negative 2.4. Okay. You have to make the sign correct based on your choice on the positive direction. Because we take upward as positive, we got A1 equal to negative G. Then you see what? This is horizontal. They make a vertical 0. You saw that? This is horizontal initial velocity. Horizontal initial velocity, you get vertical velocity equal to 0. Plus what? Plus a half. But A1 take the negative G. Means that A1 take the negative G. Negative 10. Means that negative 10. So I take a negative 10, then I got the T square. Means that I got the T square. So you have to make a correct sign on each quantity. Okay? Each quantity. Then you can, by this way, you can calculate the T equal to what? The T I calculate equal to what? Equal to 0.69 seconds. After I do that, they want to figure out the horizontal distance. Okay? They want to figure out the horizontal distance. Then this time I use delta x. Delta x. Delta x, remember, I always suggest you remember just v naught x plus a half ax t square. So I always recommend students apply the original formula. I know this uniform motion, you can simplify, but always use the original formula. Then is delta x is just range you traveled. V naught x just released. We just figure out 5.8. Okay. We just figure out at B when they move out is what? Is 5.8. 5.8. Then time is 0.69. Then I know AX equal to 0. Okay. I know AX equal to 0. So I put this 0. Then I got this range. They traveled is equal to what? R is equal to almost 4.0 meter. Okay. They falling up 4.0 meter. That's what the range they traveled. So that is back to projectile again. Okay, that is back to projectile again. Then we get the D projectile or kinematic again. Then is the last question related to some advanced. They said if the person does not let go of the rope, how does the magnitude person's momentum PC at the point C compare the magnitude person's momentum PB and B? How can you do that? They said compare B, C, then with what? With their magnitude of momentum. Is E even you learn the energy and the momentum things, you still feel this is interesting. Okay, this is interesting. They ask you that. How can we do that? We said momentum and kinetic energy, they both relate to the motion. Okay, no matter momentum or kinetic energy, they both relate to the motion. Relate to the motion, so we need to deal with the motion. How to figure out the motion? Then we said from the B to C, what's happened? from the B to C, what's happened? You said energy at B will equal to energy at C. This is conservation energy. Okay, it's conservation energy. Then energy at B equal to what? Equal to a half m VB square plus mg HB. Okay, HB the height HB. Then equal to what? Equal to C. This is a half m VC square plus what? Plus mg HC. 为啥 HC? We got this one. We just compare who is larger. Okay, who is larger? Everybody can tell HC is higher than HB. Okay, HC higher than HB. Sometimes they like to compare the value. Okay, sometimes they want to compare the value. Everybody know we said HC larger than HB. Okay, HC larger than HB. HC larger than SB. So we got what? So we got VB larger than VC. You saw that? We got VB larger than VC. VB larger than VC. Some students still not feel comfortable in this way. Okay, I told you, is 1 plus is 1 equal to is plus 1. I said if is item larger, then is item must smaller. Okay, is item larger, is item smaller. Some students still not feel comfortable on that. Okay, if you don't feel comfortable on is 1, then I tell you another way. Okay, if you feel not comfortable, then we said we do a little bit different. We said I move all these things to here. I move a half m VB square minus VC square in one side. You saw that? I move this item to another side. I move this item to another side, a half m VB square minus VC square. Then I put what? I put all the h in another side. I said hg is hc minus hb. Means hc minus hb. So if you are not feel comfortable, okay, if you don't feel comfortable, like what I said, after I write down is item equal to that item, I said hc larger than hb, then I said vb must be vc. Because they are equal value, you get each item larger, you have to make that item smaller. This is my argument. But some students don't feel comfortable. Okay, so I move each one to each side. I got half m common factor. I got VB square minus VC square. Then I move each one to another side. Then I got mg hc minus hb. Why I do that? Hc larger than hb. It means hc larger than sp. It means this is larger than 0. If it's larger than 0, if it's larger than 0, if it's 1 larger than 0, then immediately you get mb square larger than vc square. Remember, vb square larger than vc square only means magnitude vb larger than magnitude vc. It's on VB square larger than VC square. This just means magnitude VB larger than magnitude VC. But that is what they ask. What they ask? They ask you the magnitude of a person's momentum at C and the magnitude of the person momentum at B. They ask you the momentum also is way. Okay, we said momentum equal to mv is vector. Means that momentum is vector, but they ask you magnitude. They ask you magnitude. So we said I got this one larger than that one. Then I said that's only for the magnitude. But that's what they ask you. They ask you magnitude of momentum that's equal to mv. So immediately we say this is PB. PB will larger than PC. Means that. So this one a little bit interesting. Okay, a little bit interesting. Okay, PB larger than PC But that's answer is what? This answer is PC less than PB. Same thing. Okay, this answer less than PB. 意思呢？这是 answer is PC less than PB. 是 same. Okay, PC less than PB. So that is you mark here. Okay, you mark correct mark on that location. Then you get 4 credit. That is a little bit interesting. Okay, this is a little bit interesting. They how to compare the magnitude of momentum. Okay, everybody. I think that is I want to talk about today. Okay. Then what I want to recommend try your best starting do the homework. Okay. This chapter even it looks easy because we don't have much real AP physics test to present because they don't test you this way. Okay, they don't test your kinematics purely. They always combine with other things. But if you see this book, they have 2 chapters. Okay, you see this book, they have 2 chapters, a lot of practice questions because that is the foundation for mechanics. Okay, that's the foundation for mechanics. So we still want to spend some time. Then try your best, finish the homework because if you follow the procedure, work hard enough, you will have a very, very large percentage to get a great score. Okay, everybody, that's it for today. Okay, good night for everybody. Then see you again, same time next Sunday. Okay, everybody, good night. Bye-bye.